Hello, everyone. This is for whoever might have missed 219, February 19th. All the notes we covered today and some review and some new stuff. So just a reminder, I'm not really available for tutoring this week. I have meetings. You do have a Delta Math due this week, and if you never finished the last Delta Math, I did extend that. Your quiz is Tuesday, just a heads up. So just a reminder, these are two of our new formulas. We're not going to use them for the warm-up, but you're going to see them a bit today, as well as a new-ish formula, which is really just us simplifying or finding the old formula. So this warm-up is a bit of review questions. It says write the equation and find the interest earned on a $2,000 deposit with a simple interest rate of 7% for 5 years. So hopefully you remember from last week, and if you don't, I really recommend going back and watching those videos. Simple interest is linear. So I just need to find out my slope and my b. To find out my slope, well, it's going to go up by the same amount each time, which is 7% of 2,000. So to get 7% of 2,000, you're just going to multiply 0.07 by 2,000, and you get that it's going to go up by 140 each year. And then my b is my y-intercept, or my starting amount, which is 2,000. And then for the next one, we're going to do something similar. We have 1,800, and it's compounded. Oh yeah, sorry, I'm not done with number one. So there's my formula for number one, but it asks me to find 5 years. So I'm going to plug in 5, and I get 2,700. All right, now we'll look at number two. So number two, I have 1,800 deposited at a compound interest. Now, simple is linear, compound is exponential at a rate of 5% for 8 years. So I need to find my A and my B. My A is my starting amount. So I'm starting with 1,800. And my B is how much it's going up by. If it's going up by 5%, you might remember from earlier in our lessons, you're going to do 1 plus 5%, and that'll tell you 5% more than 1 times that number. So that would give you 1.05. So your formula would look something like this. Sorry, my dog is trying to play with me while I teach. I'm teaching. Here, I'll put him in view. He can help teach. Okay, so now I'm just gonna plug in 8 for 8 years, and I get 2,659. Okay, so for this, we're given these numbers, and we're gonna try to find the pattern. So we 1.5, 3, 6. Hopefully you can see the pattern. It's doubling. So this would be 12, meaning this would be 48. For B, we're starting at 24, and then we have 12, 6, and it's halving. So the next number would be 3 and 1.5. The one after that, we have 4, we have 7, 10, and then it's going up by 3s. So the next one would be 13, and then we have 16, and then the one after that would be 19. And then, so we've talked about arithmetic and geometric. You might remember that we've talked about arithmetic a lot before. That's because arithmetic is linear. So we talked about at the start of the year when we went over linear equations. And then geometric is exponential. So that's our new equations. If we look at A and B, they're multiplying. So those are geometric. Whereas C, it's addition, which is linear. It's going up in a linear pattern. Now, when it says find the common difference or common ratio, that just means for exponential, your common ratio is your multiplier. So for A, it's multiplying by 2, and B, it's multiplying by a half. And then for C, our common difference is what it's adding or subtracting by. So in this case, it's adding or subtracting by, in this case, plus 3. So it's plus 3 each time. All right, so now this is the same pattern as A, but I'm going to write the formula for recursive and explicit. Sorry, I thought I put them both up, so I kind of spoiled it. So recursive, you might remember that for R, we're going to put the multiplier, which in this case is 2. And for A1, it's my starting number in this case, or my first term, which is 1.5. And then my explicit formula, I need both of those as well. My A1 is my starting number, which is 1.5. And R is my multiplier, which is 2. So I get 1.5 times 2 into the power 1. Okay, function notation. Basically, we want to put it back into the original formula. And so, to get that, we actually already know our B. So our B is our multiplier. So in this case, it's multiplying by 2. A is my starting amount. And now I know that we've said like these are A's and stuff, but this is A1. I want A0. I want the number that comes before it. I can do this a couple different ways. I can either plug in 0 for n right here, or if I looked at the pattern, it's multiplying by 2. So to find the number before, I would just divide by 2, and I get 0.75. So my A is 0.75, because that's my actual starting number, and then my B is 2. Hopefully that made sense, because that's our kind of only new thing for today. And we're going to practice it a bit more, but if you understand it, then you're going to do really well. So let's look at our next one, our B, again. So B might be a little easier because it's slightly easier numbers to work with. We saw that this one was going by a half. So for my R, that's my multiplier. It's multiplying by a half. You can also put 0.5 if you want. And then recursive, remember you want to give it a bit more information because this isn't enough. So you kind of tack on that A1 at the end. You can think of it as part of the formula, but it technically doesn't have to be there, I guess, or isn't part of the formula. I don't know, it's kind of funky. Explicit, it is part of the formula. So I'm going to put my A1 and my R. My R, again, you can put 1/2 or 0.5, but A1 should be 24 because that's what it's multiplying by each time. Okay, so then for function notation, I want to put this in the original type of equation. So I already know my B. I know that's multiplying by, let's say, 0.5 or a half. I want to find out my starting amount. So this is like A0. So I could plug 0 in here, or I could look at the pattern, which potentially could be easier. So I'm going by a half each time. Or backwards, you can see I'm multiplying by 2. You could also divide by a half. Either way, you should get 48 would be the number that would come before. So this would be 48 times 1/2 to the power of x. And that is how you write it simplified. All right, this one, my recursive formula looks like this. It's a little different because this is linear. So instead of multiplying, it's either adding or subtracting. In this case, it's adding by 3 each time. And then my first term is 4. So for here, I need to put my A1, which is 4, and my D, which is what it's going up by, which is 3. Now to find function notation, we could do 3 different ways this time. So I know my M. My M is my slope, which is what it's going up by. It's going up by 3. So I know this is going to be 3x, or something plus 3x. I could plug in 0 here to find my b. I could look at the pattern. So a lot of people did that in class, and that's probably the easiest way. So it's going 4, 7, 10. So if I went backwards, I could subtract 3 from 4. Or another way that I think they expect you to do a little bit is simplify. I technically can simplify the exponential, but you haven't really learned exponential rules. But here I could simplify because whenever I have a number in front of parentheses, I can distribute. So this would become 3n minus 3. And then I can combine like terms, and I get 1 plus 3x, or 3x plus 1. Both are the same thing. So again, you could have figured out the number before 4 was 1. You could have plugged in 0 here and got 1. You could have simplified and got the equation 2. Okay, so this one, we're given the recursive formula, and we're going to put in the explicit. So I can figure out my A1, because it literally says it right here. And then I can figure out my R, because that's this. This formula, remember, is R times A n minus 1. So if I'm missing my R, it's going to be 6. And then for the next one, it's kind of flipped. I want to put it in this formula. My R is my multiplier. And looking at this, it's multiplying by 1/3. So the R will be 1/3. And then my A1 is my starting amount, which is 27. And I clicked a little too quick, so you saw that already. Okay, we then did a matching activity for most of the rest of class. I'm going to do some of this with you. Feel free to pause at any time if you want to try on your own. It's pretty easy. So we have 2 different sides. We have geometric and arithmetic. Geometric is exponential. So let's look for an exponential example sequence. As I go through, I get to E. E is 9, 5, 1, negative 3. That is not multiplying by a number. That's a linear pattern. So I'm not going to use E. Okay, I keep going, and then I come across I. 160, 40, 10. That is exponential. So that is going to fit a geometric sequence. So now I want to find my common ratio. That is your multiplier. Now we know it's going down, so it's going to be a fraction. If I looked at these two, if I looked at 10 over 4, you might can think of what that is as a fraction, or what that multiplied by, 10 over 40. And you'll get that it's multiplying by 1/4. So that best fits D. So in the next part, I'm going to put B. And then for recursive, if you look around, you should find one where it starts with 160 and it's multiplying by 1/4. And you get K. So right here, we're going to put K. For explicit, similar idea. You should have your A1 times R, which is 1/4, to the power of n minus 1. And if you look around, you'll see D. D best fits this description. For function notation, there is a dead giveaway which one it is, but let's kind of break down our function notation. So we already know my R, or my B, We know my multiplier is 1 over 4, but we don't know the starting number. I could plug 0 into this equation, or if we looked at the pattern, this is 1/4, 1/4, or backwards, this is times 4, times 4, times 4. And so this would be 640. Or you could divide by 1 over 4, and that would also give you 640. It's the same as multiplying by 4. So my A is 640, and my B is 1 over 4. So if you look for which one that best fits, it best fits O. O. Right, so now we're going to do an example of arithmetic. We already saw that E was arithmetic. It's following a linear pattern, so we're going to put E here. And then for my common difference, that's asking what it's adding or subtracting by. And we can see that it's going down by 4 each time. So I'm going to look for a common difference of -4, which is M. So now I'm going to look for my recursive. It should be subtracting by 4 each time, and it should start with 9. So you'll see it best fits R. And then for my explicit, it's a similar idea. My A1 is 9, and it's subtracting by 4 each time. So there's only one option that best fits that, which is C. And then function notation. Again, you can do this a couple different ways. We already know our slope, which is -4. It's going down by 4 each time. But we don't know what comes before 9. You can probably figure it out if I'm subtracting by 4 each time. Or you could plug in 0 here for n. Or if we looked at or if we simplified this. So if we distributed -4, you get -4n, and then plus 4, because -1 times -4 is plus 4. And then you can combine like terms, and you get -4n plus 13. So you should get -4. If you plug in 0, you should have got 13. If you added 4 to get the number before 9, you should have got 13. So this best fits L. So we're going to put L here. Okay, I am hoping you're finding it pretty easy. I really would like you to try the next couple on your own. This is, you can see what's left, so feel free to pause, and then I'll start to go through the answers. So your only geometric pattern that's left is Q, and it's multiplying by 3. So my common ratio is 3. And then my recursive, there's only one where it starts at 2 and it's multiplying by 3. That's G. And then similar for the explicit, there's one where it's multiplying by 2, and 2 times the multiplier, which is 3. Function notation. Now, you could think about this a couple different ways. So here it's multiplying by 3. So if I divide it by 3, that would be 2 over 3. Or again, you could plug in 0 right here, and you would also get 2 over 3. So it's 2 over 3 times 3. And then this should be pretty easy because we have barely anything left. The pattern is P. It's going up by 3's, so the common difference is 3. And then there's only one example where it starts at 2 and it's adding by 3, which is J, for recursive at least. And then similar for explicit, it's starting at 2 and adding by 3 each time. And then if I tried to find the number that came before, I could subtract 3 and you get -1. I could plug in 0 for n, or I could distribute this 3 and then simplify. Either way, you should get 3x minus 1, or minus 1 plus 3x. Okay, I'm hoping you found today's potentially even easier than yesterday. Yesterday's was a lot of information, but today's was just a lot of review, with the new twist of finding the original equation. Anyway, hopefully it made sense, and let me know if you have any questions.